It's 1 a.m. in the morning and I want to finish this methodology section before my head hits the desk. I don't have time for complex formulas and neither do you, so let's use Raosoft to get that sample size. Now all you have to do is go to raosoftcalculator.com and then you're going to see this interface like this. If your study is looking for a proportion or your study has something to do with Cochran formula, you can use this calculator. So the first item here you can see is population size. Now this is simply the total number of your population and it's in this population that you intend to draw your sample size. So for example, let's say a hospital has 700 doctors. We are going to include 700 here. The next one is your margin of error. Now the margin of error simply is the amount of error you are willing to tolerate in your study. So I'd like to stick with 5%, but you can do 10% if you want. And the next one here is the response distribution. Now this is simply your assumed proportion. This is simply the number of people you think are going to see yes or are going to have whatsoever it is that you are looking for. Let's say you're studying something that has to do with bullying in healthcare setting. Now the response distribution is asking how many people do I think are being bullied in that healthcare setting. Have you guys experienced bullying before in your workplace, in a hospital? I don't think I've experienced it before, except if humiliation counts as bullying. Like, when they ask you something and you don't know, they shout on you. If that counts as bullying, okay, I've been bullied before. But if not, I don't think I've been bullied before. Okay, let's go with the study that was conducted in Plateau State. So here you can see that it says bullying was currently being experienced by 74 people, in brackets 59.7% of respondents. So this 59.7% is what we are going to use in our calculation because it is our assumed proportion. That's what we are expecting to find. And then this last one is your confidence interval. Now this is simply how confident you want to be that your findings or your results fall within your margin of error. So you can either go with 95% or 99 or 90% confidence level. Now the next thing for us is just to click on calculate and we are going to have our answer. Now here you can see that we have the required sample size in bracket, which is infinite population, and the answer is 370. And then we have the adjusted sample size, which is in brackets the finite population with 243 samples. Now this is why I told you that you can use this calculator if you know your population and even if you don't know your population. So if you use your Cochran formula without the finite population correction, you will arrive at this 370. But if you apply your finite population correction, you will arrive at 243. So what this means is that the 700 population size I put was used for this finite population, for this adjusted sample size. But here, the one with 370, it was not used at all. Also, if you don't know your population size, you can still use this formula, just that the adjustment will not be made because you don't know your population size. And also, if you don't know your response distribution, which is the one you get from the prior literature, you can still go ahead and use this formula with 50%, which is going to give you the maximum sample size that you will need to conduct your study. And if you look here, you see that the answer is 385, which, trust me, if you use your Cochran formula, your complex statistical formula, you're still going to arrive at the same answer. If you're wondering, can you use the same calculator if your study is a case control or a cohort study? The answer is no. But you can use this one right here, and I'll see you in my next video. Bye.